Good day, everyone. I'm Rob Hewitt, and I'm the Director of Global Business Development for Spatial DNA. Here at Spatial DNA, we design and build no-code integrations to connect solutions to your key business applications. Some quick background on our company. We've been around for 12 years. We started as a system design company in the aviation sector. We built our practice around mission-critical systems. This meant the design must not fail. We took this experience to local government space, which is where most of our work is now. We continued to expand our work in aviation and other industries like retail, manufacturing, and real property. We now focus primarily on application integration. Our product is a no-code platform that understands spatial information. This is very important if you're in an industry that needs to leverage geographical data, or in an industry that manages or builds facility or infrastructure assets. We've handled some complex integration challenges. We understand that data is never perfect, and we can always design around any data deficiencies. Your host for today's webinar will be our founder and CEO, Todd Lewis. Todd is on a mission to connect systems, transform work, and engage the creativity of his customers so that they can grow their communities by digitally transforming their businesses. Todd has been active in GIS technology space for 25 years and is a recognized expert in application and data integration. Todd holds a BSc in geomatics engineering from the University of Calgary, and he is an active member of the Entrepreneur Organization, a group dedicated to supporting entrepreneurs and growing the entrepreneurial spirit globally. Todd, on to the show.
Hey, Rob, thanks for the intro. And thank you to everyone who's joined us today for a deeper look into how API integration works. We're going to start our webinar today with a spooky campfire story about how insufficient requirements and use cases can deadlock projects. Then we'll explain what an API is for anyone who doesn't know. We'll discuss what an API should do, basically what you should know before buying software, so they don't get screwed and end up with an expensive software system that doesn't meet your needs. We'll go through API licensing, which could determine how you can access your own data. And finally, we'll talk about how to determine whether a vendor's API can meet your organization's needs. Then we'll summarize, offer some advice, and answer some questions. If you have a question during the presentation, drop it in the chat, and we'll answer it at the end. And now, the horror story. It was a sunny Monday morning in the town of Springfield. Bob, a field technician for the town, sat down at his desk and took a sip of fresh coffee. It tasted terrible, but it made him feel alive. On his computer, Bob opened Springwood's time tracking system, Punchy Clock, and began to enter his work hours for the previous day. Punchy Clock was a system that printed Bob's paycheck, so Bob always took exceptional care to record his hours correctly in both the hours and minutes field. If Bob made a mistake during entering his data, he'd be sure to notice when he got his paycheck. After entering his hours in Punchy Clock, Bob enters hours in another system, WorkyTrack. WorkyTrack was the system that Springwood used to record work orders. Bob entered his hours in WorkTrack, but in his 8 years working for the town of Springfield, he had never noticed the minutes field. Later that week, Bob's supervisor, Jeff, was going through work orders. Jeff noticed that Springfield's new field technician was completing work rather quickly. He inspected the numbers further and realized that Bob and most of the other field technicians were not entering their time in the minutes field of WorkyTrack. Jeff inspected some more and was paralyzed by what he saw. He picked up the phone and dialed 911, which was the extension of one of the finance managers. The following week, Springwood's finance team met in the East Boardroom. They named names, they numbered numbers, they numbered more numbers, and the more numbers they numbered, the more they realized the numbers were horrifying. Bob wasn't the only field technician who wasn't entering time in the minutes field. There were more, many more, and nobody was rounding numbers down. They were all rounding up Springwood's finance teams had been overestimating their labor, and the executives were planning hundreds of millions of dollars of capital expenditures based on this flimsy data. But what was even more horrifying was the potential for exponential errors. Bob entered 7 work hour orders per day on average in both systems. He worked 5 days per week and 50 weeks per year. Springwood employed 40 field technicians who are making a whopping 140,000 entries per year, the same data, 2 systems. And this had been happening for years. After much discussion, the town of Springwood decided that they needed to designate a single system to capture all of this data. This way, field technicians would only have to enter their time once, and the horror of data inaccuracy would be eliminated for good. Springwood decided to integrate Punchy Clock and WorkyTrack. The project team was pleased to learn that Punchy Clock had an API that could receive data for work hours and pay adjustments from WorkyTrack. This will be easy, they all thought at the exact same time. Unfortunately, Punchy Clock had other plans. The project team was horrified to discover that Punchy Clock's API did not have the methods to write all of the required data from WorkyTrack. This horror story was based on real events. The names of people, systems, and places have been changed to protect the guilty. Unfortunately, Springwood's situation is not uncommon. This scenario leads us to today's topic. How does API integration work? Will an API solve your problems? So first, what is an API? An API is the acronym for Application Programming Interface, which is a software intermediary that allows 2 applications to talk to each other. Each time you use an app like Facebook, send an instant message, or check the weather on your phone, you're using an API. An API works very similarly to a bank machine, an automated teller machine. At a bank machine, you need to do a few things. You need to do a few transactions. You want to look at your current balance. You may want to take some money out. You may want to put some money into your account. The first thing you do when you go to a bank machine is you take out your card and you put it in the machine and you enter your PIN number, personal identification number. This is how you authenticate and let the bank machine know that you're the one that is allowed to transact against certain accounts. Similarly, in an API, there is an authentication mechanism, a system, whether that's the user interface, a piece of middleware, a programmer, needs to authenticate against the application's API by providing login credentials and receiving back a token that they then use for accessing that API for further requests. In a bank machine, you send a request to retrieve each cash. You enter the amount of money you want, and the bank machine gives you the money. It doesn't care what you do with that money, it just provides that money. And the API responds very similarly. You enter some information about what you're looking for, and the system provides back some data. Whether that data gets put in another database, in a dashboard, in a user interface, the system doesn't really care. If you want to deposit cash into an ATM, you take your cash, you put it in to the ATM, and it updates your balance. On the API, it's the same. It takes your data. So the system or the user interface is providing a piece of data to the API. The API validates that the data fits the internal business logic of the application before updating the database. So what should an API do? When we look at any system, it can have 4 major operations that occur throughout the data lifecycle: create, read, update, and delete. So sometimes we use the acronym CRUD, C-U-R-D, for this process. But for most systems, it's best practice not to allow delete operations through an API. Often a more useful operation is search. And if you're reading a lot of records, some systems enable a batch read process called extract. So the acronym that we use is CURES, C-U-R-E-S, create, update, read, extract, and search. So all the major business objects in your system should be creatable: a new account, a new asset, a new journal entry, etc. And sometimes there's an hierarchy associated with the creation of business objects. So for example, you can't create an attachment in a customer relationship system without having an associated case or a contact or an account to attach that document to. You need to know the identifier of the parent entity to create the parent-child relationship between the two objects. So API documentation will show post methods to create new business objects. So make sure the business objects you care about have a post method indicated in the documentation. Sometimes there's fields or attributes in a record that you just need to update in your system. So through the API, there's two issues with an update. If a business object already exists, you might need to identify that record through its unique identifier and then change the specific values for said record. An API can be handled, an update can be handled in the API through either an update or a post request. So if you use a post request, you're overwriting the entire record with new information. Whereas an update request, you're just updating the subset of fields that require an update. Some more sophisticated software APIs also support an upsert method, which is a combination of an insert and an update. So it'll either update the record if it exists or create a new record if it doesn't exist. You may need to extract information from your system. The read operation enables you to retrieve one or more records. If you look at any API documents, you will see get methods to retrieve records from the system. Some APIs have batch read methods, we call these extract, to download a large number of records. This method is useful if you need to periodically retrieve large volumes of data, such as timesheet entries to process payroll on a biweekly basis. Last but not least, search is a function that is often missing or not obvious in many APIs. When we're doing transactional updates to a system based on a message, we often need to find one or a subset of records that require an update. Or if we're retrieving records, a read, we often want to just retrieve records created since the last time we made a read request. So we need a time window that we search on. So search methods are a critical mechanism for retrieving transactional information or selecting a subset of records to update. Next, we'll talk about API licensing and how it can affect access to your data. There are three license patterns that we tend to see. The first is an open license or a public use API. There's no special licensing cost allocated to access or use this API. So think about embedding social media content into a website. You're using the API for Facebook or Twitter to retrieve that content and post onto your website. API license is the next type of licensing pattern. And this is a special license to access the functionality available through an API, often requiring an authentication method. License tiers may also enable additional functionality. API licenses can be licensed per user or across the whole organization. So for example, when we're integrating with Salesforce.com, we're consuming a user license to enable all of the integration workflows against the Salesforce API. And then finally, the other license type that we see often is what's called a metered license. So this type of license is giving you a number of transactions that you can use against the API or an API object per month, right? So this might be noted in hundreds of thousands or millions of transactions per month that you're allowed to consume before you need to purchase the next tier of metered licensing. So one example that we use often is Mapbox.com. You have several 100,000 requests that you can make to the get maps function, for example, per month. So making money with an API. So if we look at it from the software vendor's perspective, how do they use an API to make money? And there's a couple of things to remember here. So first of all, the software vendor is providing their access to your data. They're prescribing access to your data through either a user interface and applications that the user can interact with, or through an API. The problem for the vendor with an API is this can often avoid a user subscription license, right? So you can replace the functionality that might be sold through multiple user licenses with an API. So APIs often have an additional charge that's through a license or transaction metering to compensate the vendor for this loss of revenue by not having as many user subscriber licenses. For companies that manage financial transactions, some of them often license their use of their APIs or even their whole product based on the transaction volume in terms of dollars that go through on a monthly basis. All right, so they might charge you by number of transactions or by percentage of the value of the transactions that you're consuming. Some systems and some software vendors also partition their functionality together with integrations to some key systems at different licensing tiers. So you think of a basic, a professional, and an expert license. You might have integrations to Microsoft Office 365, for example, as part of your basic license. And then as you move up, you might have additional licenses available for Salesforce.com integration or something more advanced. So some of the larger software systems, the integrations may be pre-bundled together at higher license tiers. And just like how we can group functionality, feature functionality for licensed software and the user interfaces into tiers, APIs can often be grouped into licensing tiers as well. So the API can be limited to the data that it's able to access. And so it might be able to read all data and write only portions of data in your software system at each licensing tier, or it might activate internal business logic that's available at each licensing tier that can be triggered through the API. So basically, vendors can lock up your data by dictating access either through their licensed applications or by an API. Either way, you're paying to access your data. Okay, so when you're acquiring software from a new vendor, there's some things that you need to consider. So one is that there may be a separate licensing charge for your API. So what kind of licenses do you need to support your organization? Do you need an API license to connect your current systems? So if you have integration requirements, typically you will need an API license or API access to be able to do that. And then lastly, make sure to get a hold of the vendor's API documentation so that you can review that and understand whether it's meeting your requirements. You may also need to model the number of transactions in your system or check the feature function of components in the API to select the correct license tier of the API. And finally, comparing your API license costs, just like any other business case, look at some of the following considerations. So savings in time by automating. Can you replace some manual processes? Can you reduce the effort for doing certain functionality? Can you reduce the risk of automating of data entry in multiple systems like we saw in Punchy Clock and WorkyTrack by automating the data entry? So making the creation of new data available in one system and using integration and automations to update your other system with that information. The last thing to consider when you're acquiring a software system is how the vendor supports the API and versions of the API. Do the versions of the API move in lockstep with the software user interfaces that are bundled at each functionality tier? Or what we often see is the API often trails behind the capabilities of the software in terms of the functionality available. So sometimes there's a gap between what's possible to do in the user interfaces for your software and what's available in the API. What about your company needs then? So first, you need a way to read and write all of your data. So this is the CURES, C-U-R-E-S, create, update, read, exchange, search capability that we discussed earlier. Some integration patterns that we use require you to query or search for information on latest transactions. So you need a way to find changes and latest transactions in your system. Those are often triggering events in another application. Custom fields. So often when you go and implement a new software, you're going to create custom fields as part of your implementation and configuration of your system. These custom fields might be used to catch information that's specific to your organization, or triggering specific workflows, or maintaining some sort of status. Many APIs don't have the capability, though, to expose custom fields to the API. So often, if you're trying to integrate your system with an existing system, it can be difficult if you have custom fields, and this often requires some sort of workaround to add in the information into the custom fields. So ask your vendor, your software vendor, when you're acquiring the software, if their API has a way to expose custom fields to integration platforms. And then the last thing is we often need to search on custom fields in an API. So part of the reason for adding these custom fields is often to organize your data and to be able to filter based on mechanisms that might not be part of the sort of the base configuration of whatever platform you're buying. So that ability to search on custom fields through an API is really important. So there's a few gotchas that we've run across in sort of our last 10 years or so in API integration. One, create and update operations are often missing from key business objects and properties. So you may have an API available, but that key business object, the ability to create a contact or update an account, may be missing from the API side. So don't assume just because you can create and update information in the user interface that the API supports that operation. The API should also enable visibility into custom fields that are created as part of your software configuration. And also keep in mind that search capabilities are often missing from APIs, especially those time-based searches that allow us to look for latest transactions or queries within a certain time window. That can be really important from an integration point of view. And lastly, as a customer, API licensing may be an afterthought, right? It might not seem important to integrate the new system that you're getting with your existing technology, or maybe a new application that you're going to be acquiring in the future. But the best time to negotiate your API licensing is when you're acquiring the product in the first place. That's when the vendor is most open to negotiating various parts, especially if they're not going to be responsible for some of the rollout requirements around APIs and integrations. So protecting yourself, the key thing that you can do to protect yourself around APIs and what they can do is to get the documentation. So a vendor should be able to provide you with API documentation that is in a specification called Open API or Swagger. So that kind of specification gives developers on your team the ability to read, understand, and test data inputs and responses against the vendor's API before you buy the software, to make sure that the capabilities of that vendor's API meet your current and future needs.
All right. Thanks, Todd, for explaining all this API stuff in detail. Great story, too. So to summarize, here are some of the things you should do, ideally before buying your software. First of all, get the information. So ask for the API documents. Be aware of any API limitations. Get clear on all fees involved. And understand how the API allows you to access your data If you need to hire a consultant to guide you, having that expert guidance can end up saving you money in the long run. Spatial DNA does provide a consulting service for this very thing. We can help you get clear about your interface requirements, which can save you money during your software implementation. We offer an integration design agreement through which we evaluate your systems, determine your requirements, and provide a framework and cost so that you're equipped to make important decisions. So give us a call or email if your organization needs some expert guidance in this area. Before we move into question period, I want to let you know that we will be hosting another webinar in June. We will be revisiting our first session in this 3-part series and discuss best practices around the topic of master data management. Stay tuned for a date in our follow-up newsletter after this webinar. Now we'll open the floor for questions. Would anybody like to get on camera or audio and ask live? If so, please feel free to turn on your camera or put up your digital hand. If not live, I invite you to put your question into the chat now. Thanks again, everyone, for your time today. All right. Here we go. First question. What are flavors of API? SOAP versus REST API?
Yeah, so I guess the key differentiator between SOAP and REST, SOAP is an older standard, simple object access protocol. And what that one does is it works very similar to how you work with an application. You log in and the software vendor supporting the API opens a session and you log in once and you create all of your queries within the bounds of a session. A REST API works more like a web page. You have a single request and a single response, and you need to authenticate or provide an authentication token with each request. The key difference between the two is where is the state of the application maintained? Is it maintained on the software vendor side in the application? So SOAP basically is a protocol that would maintain that state of where you are in your transactions. Or if you're on REST, then you are responsible for understanding where you are in a work process.
Where do I find API documentation, Todd?
Okay, so that's kind of a bit of a loaded question. So some vendors post that documentation publicly. And if you look in the support section of their website, you'll be able to find their API documentation and be able to browse and peruse it. Other vendors only provide the API documentation with their licensed software. So you have to actually have a user account on that software to be able to access the API licenses. Most software vendors will allow you to have a trial version of their software. And when you request that trial version, ask if you can also have access to the API documentation so that you can read, peruse, and understand how that API functions.
We've hired a system implementer to build this project and connect these systems. Is this not something that they have already taken care of?
So it depends on your system vendor. So sometimes when organizations go out for bid, they're looking for a software vendor or system implementer with software vendor to implement the services at their site. The issue that we find is that requirements around the APIs are often underspecified. So what this means is they can be vague. The use cases or the business processes that you're trying to connect these two applications for, these 3 or 4 applications, the business process underpinning them is often missing, not documented, not provided to be able to bid. So what often happens is the vendor is making a series of assumptions around what you want, and they're not really looking in detail at how their API can meet your requirement.
Great. And Herman, you have a question. I saw your hand up a moment ago.
Yes, question regarding API authentication best practices. You know, as I've gone through the SOAP and REST services, there's so many different flavors from SAML to OAuth. It's like you jump from one software to another software, it just gets complicated.
Yeah, and so I guess what I'd say is a lot of software is tending towards supporting SAML, but not all software is there yet. So OAuth version 2 seems to be sort of the common standard across all software. So there's OpenID, OAuth 2, and SAML are the main ones that we see. There's also basic authentication, which nobody should ever use. Yeah. Typically, especially with REST APIs, you're working with a token service. You're getting a token, and some software vendors also, you're essentially registering your application against that software vendor. So there might be additional authentication information, such as a secret key, in addition to like an API key that's shared. So when we do Salesforce, for example, there's about 5 pieces of authentication information that are provided to connect into a Salesforce instance. So that would be sort of an example of a more rigorous authentication scheme that we've seen. Does that answer your question there, Hemant?
Yes, it does. Thank you.
Okay.
All right, we're trying to integrate a legacy system. What do we do if an API isn't available?
Okay, so a legacy system will often be on-premise. If it's on the web, there tends to be relatively little that you can do on a web-based system. It'll often have an export and import function so that you can pass a pre-configured file for import or export. If it's an on-premise system, when we look at integration, we kind of take it in a prioritization. So we look at API is the preferred mechanism to integrate with. There might be a web service that's created. So that's an older way of doing integrations. You might be able to create what we call a database interface table. So that's getting into sort of the data back end. And part of the reason we wanted an interface table is so that we're triggering the application business logic so that referential integrity is maintained in the database, as well as some of the business rules around how data should be inserted are maintained. And then lastly, it's direct database access. When we're getting to the database access end of things, we prefer to just do reads, not writes against that data, because you can cause all sorts of problems with sort of unknown business logic that's sitting in that system.
Okay. Next is on the topic of Swagger. I thought it only supports REST.
Yeah. So it does only support REST. There is on the SOAP side, there's the web service definition language that supports more of the various application calls for a SOAP service. And that document is something that's provided once you connect to a SOAP service. It's a deliverable back from a SOAP service. And that's supposed to provide essentially all of the system calls in and out that you can make against that service. So it's a bit of an auto discovery mechanism that's built directly into SOAP. Swagger and Open API were built because there is not a similar capability for REST interfaces.
Great, thank you, Todd. Well, that wraps up questions, unless there's any that are going to trickle in here. And we're ahead of schedule, and we can give you 20 or so minutes back to your day. And we want to thank everybody for taking the time again, and look forward to seeing you again at our next event.
Okay. Thanks, everybody.
Thank you.